Okay, great. Yeah, I had to disconnect and come back. So, okay. So this is just a quick YottaDB update. And the main theme of the message is we've just been chugging away, making steady progress. And it's one of those things where, from one day to the next, or 1 week to the next, it doesn't look as if we've accomplished a lot. But we've managed to do a fair amount over the last year or so since the last update that I gave you. So these are roughly the things that I'm going to talk about. Give you a quick business update, talk about what we're doing with the YottaDB core, talk a little bit about Octo and DevOps, and talk about the ecosystem and then the roadmap of where we're going. So the business update. So basically, the software is free, but the people are not. And this means that 100% of the software that we develop is released under a free and open source software license. We prefer and use AGP and V3 wherever that is possible, and so far we haven't run into any issues with that. But again, the people are not. So we fund software development by support contracts, and these are support services with SLAs, and those are on commercial terms. And we have a couple different tiers. One is the business hour support, where we respond within one business day, and then there's a premium tier where for production issues you can call us and we respond 24/7 within 1 hour. And in this business, the way you make money is by minimizing the amount of time that you spend on support. So we have the incentive to make the software absolutely as robust as possible. And what we're really selling with the support contracts, the value we're adding is peace of mind. But that's the basic business model. And where we are right now is we have revenue. Hello, someone's coughing or sneezing. Could you mute your mic, please? So we have revenue from 3 continents at the moment. In fact, the majority of our revenue is actually from outside the US. And the interesting thing that's happened in the last year, so a year ago, all of our revenue was from people using YottaDB as an implementation of M. But that has changed. We now have people buying support who are using non-M languages, and specifically Go, which is a language developed by Google. And we also have support revenue from customers using Octo, which I'll talk about in a minute. That's our SQL engine. We've been profitable since 2018, but it's one of those things where what I'm trying to do with the business is plow all the revenue back into software development so that we continue developing the software. So at this point, the aim is not really to make it into a big profitable business. Someday I have no objection to making a lot of money from this, but we are doing this as a commercial business. But the big difference between, let's say, Jeff Bezos and me is he's working on his 200th or 300th or whatever billion, and I'm still working on my first billion. Okay, so let me talk about MetaDB itself. So this is our obligatory marketing slide, and again, much of this is familiar to anyone who's used M, mature, high performance, hierarchical. But the other key is language agnostic. So what we're really trying to do with YottaDB is take the mumps is basically both the language and a database, as all of you know. And what we're trying to do is separate the database from the language and make that database available to users in other languages, so that they get the same benefit of the tight coupling between the database and the language that end users have always enjoyed. So the basic architecture of YottaDB is like this. At the core is the data organization, which is primarily the database, but it's also local variables and also mlocks. So that's at the core of what we do. And if you look at the orange arc on the lower right, that's the traditional M language subsystem, and M application programs could always run on that M language subsystem. So that's the traditional M implementation. But the other thing that we did, which is new, is we created a native C language API. So you can directly access the local and global variables and locks from C without the need to actually touch any M code. And so from the C language, you can go directly to the database, and that means that C application programs can access the database and the variables. And it also means, since C is pretty much the lingua franca of computing, that other languages can use that C API to access the database. So we have a number of different languages. Go is one that I've talked about. We also have a Perl API. There's a Rust API. Python is pretty much in beta test and doing some final testing before making it official. So there will be multiple languages that you can use to access the database. In fact, there are languages. And the way that we're packaging the software is we call them wrappers and plugins. So wrapper is something that goes around YottaDB, and it's like a library or a package or a module or whatever term is used by each language. And we want it to feel and be packaged natively to each language. So every language should just say, okay, here's another library that I'm installing. So you install that and use it, and that's how we've done these languages. And by the way, a couple of them are from the community. Node.js was done through Nodem, and that's done by David Wixel. I'd like to acknowledge that. And the Perl wrapper was done by someone in Austria called Stefan Trabi, who unfortunately passed away recently. He just went to sleep one day and never woke up. But it's there, and it's very robust. At some point, we will need to take it over and maintain it. And Python is in field test and quite usable today. At the other end, we have plugins, and plugins are actually installed under YottaDB in a plugin subdirectory, and they extend the core functionality of YottaDB. Hello? Is there a question? I guess not.
I don't think so.
Okay, so there's additional core functionality of YottaDB, and these are things like Octo, which we'll talk about, and then the POSIX plugin, which allows M code to call POSIX functions and so on. Now, in terms of the code base, what we're doing is we're staying compatible with the upstream. So as we do each YottaDB release, we merge releases from the upstream GTM into our code base. And one of the things that we do is, because GTM releases the source code, but they don't release the automated tests, we have to create our own automated tests for that code, which means that we sometimes find and fix bugs in that code. And the sad thing is that when we first started doing this and we found bugs, and we found a particularly serious bug in the GTM code base, which had some unfortunate consequences in a couple of production sites. And we reported it back to them, and we had a fix as well, and they didn't take the fix. And then they tried fixing it, and their fix was imperfect, and then they fixed it again, and then it was decided as a much better fix. So eventually, we're adopting the final fix, but this is kind of some of the issues that we run into. But because of the fact that we're taking all of their code and we're testing it and merging it, so we have all of the functionality that's in GTM plus all the functionality that we implement on our own. And at this point, we're, I would say, a little over a year behind, which is a safe distance. I want to be somewhere between 6 months and a year behind GTM releases to give them a chance to when they put out a release, if they did something really problematic with it, they can correct it and we'll know about it. So I don't want to grab a GTM release as soon as it comes in and merge the code. And at this point, as far as most VistA applications with all of our customers are concerned, that seems to be fine. So because of that, we have an upward compatibility guarantee for the customers. So essentially every YottaDB release is guaranteed upward compatible with the GTM release that it is built on. And the exception, as I said in the release notes, is if there's an enhancement in YottaDB that isn't in GTM and you have code that depends on the absence of the enhancement, then that's not going to be upward compatible. That's not going to necessarily work. And similarly, if you have a bug in GTM that we fix and you have code that depends on the presence of the bug, that's going to behave differently. But otherwise, it's essentially 100% upward compatibility. And for our customers, we have this guarantee, and we've had this guarantee since the beginning. Okay, let me talk about Octo. So Octo is a SQL database engine. So you can do create table, select. We're working on update and so on, update, insert, and delete. And the tables are stored in global variables. So Octo is a YottaDB application, not a GTM application. And this is because it has functionality that we've implemented in YottaDB, which GTM has not taken back in. In fact, they haven't taken anything back from us. And if you're running a GTM production instance, you can run Octo on a SI replication instance from the GTM production instance. We have at least one user that's doing that. And if you're running a production instance on YottaDB, again, you can do SI replication from that to an Octo instance. So this is essentially the architecture of Octo, which is that, so in the purple boxes with the orange letters, that's your production system. And if you look at VistA, the schema layer is FileMan, and you have applications that go through FileMan and access the production globals. Now, in a development environment, you can run Octo in that same instance, but in production, you don't want to do that because you don't want your queries having an impact on response time and system load on the production system. So what we do is we set up a replicated instance, and the replicated instance, this will use a type of replication called SI replication. And whereas the more traditional type of replication is business continuity replication or BC replication. So if you want to ensure business continuity of your production system, you would have one or more BC replicas of the production system. But here you have the SI replica, and that again has all of the replicated globals that replicated in real time from the production system. And then you take the schema that's in the schema layer of the application, and you create an Octo DDL. Now, in the case of VistA, we have a FileMan to Octo DDL mapper. So it looks at SQLi on the VistA side, looks at and then creates the create table and the table mapping. And that DDL is then imported into the Octo SQL engine. But in general, the DDL is whatever create tables that you might have. And you have that, feed that DDL into the Octo SQL engine. The Octo SQL engine then compiles that DDL and stores the compiled form in Octo global variables. So there is a separate YDB Octo region, with typically, this is how you'd set it up, which contains all of the Octo global variables. And then when you have a query coming in, and the query can be either directly input to Octo at a terminal session, or it can come in from a client over JDBC. And we have adopted the Postgres Y protocol. So hopefully, as we add support for various metadata that Postgres clients expect, we can have more and more of the Postgres clients working with Octo without needing to write our own JDBC driver. and that goes into a Octo server, and that's nothing other than something that takes the JDBC from the client, converts it into a SQL query, puts that into the Octo SQL engine, and in this case, it actually happens to be running within the address space of the Octo server. And then it it takes that SQL, looks at the DDL, and then generates executable M code. And that executable M code then accesses the replicated globals and then returns the value. So essentially what we have is SQL that gets compiled down to M, and the M gets compiled down to object code that makes direct access to the globals. So the goal is to make it run absolutely as fast as possible. And so anyway, this is the basic architecture. Now, a couple of interesting things that we do. Obviously, if you're replicating from the production system, it means the data is not static, it's constantly changing. So Octo actually
Bhaskar, we just lost your audio. I don't know if you can hear me.
I'll put something in the chat.
Yeah, I was just trying to put that in the audio. Let me see if I don't know what telephone he's using. I could maybe call him.
Yeah, I was going to say I could text him as well.
Oh, there you are. So you knew you disappeared?
Is the sound any better? I was on, I dropped off the computer audio and I was using the phone, but looks like the phone disconnected, whatever.
Yeah, okay. Now I'm not sure whether we lost I'm the only one that lost your visual also, I think.
No, I stopped sharing, so I'm going to go back to sharing.
Okay, good. Okay.
Can you hear me now?
Yeah, I can hear you now.
Oh, wow.
Okay.
And he's back. So, yay, Bhaskar. This is Dave Whitten, by the way.
Okay, so where was I when you stopped hearing me?
I'm trying to remember. You were talking about trying to make it as fast as possible.
Okay.
I remember you talked about replication.
Okay.
Yeah,
sorry,
that's right.
Okay.
You were starting with that. That's right.
So we have the data in the Octo instance is not static because it's constantly changing because of replication. So what we do is Octo generates triggers, and these triggers then update the Octo globals every time the data comes in from the production system and gets updated. Whatever metadata, cross-references, or whatever that Octo needs to access the data gets automatically updated. And because of the transaction processing logic under which triggers execute, the triggers ensure that the metadata and the data are always in a consistent state. And there are other optimizations as well, and we keep doing more of them. So if there's a query that comes in that says select all patients where the patient name is Bhaskar, then it will actually say, hey, Bhaskar is a literal out here. I'm going to generate code for select all patients where the patient name is a variable. Make that into a function, call the function with the parameter of Bhaskar. And now if you have a query coming in that says select all patients where the patient name is Nancy, it will then say, hey, I already have the code for this. And then it'll call the function by plugging in Nancy as the patient name. So it has optimizations like that, and optimization is a journey, not a destination. So there'll be a series of those over time. And this is an example of using Octo to query some Cynthia data. And again, the client that we officially support right now is Squirrel SQL. And this is mostly, we don't support a whole lot of other clients because each client has its own expectation of what the metadata looks like that Postgres provides. So over time, we're just going to add in some cases fake the additional metadata so that other clients work with with Octo. So right now we have we have the Squirrel SQL working, and I think Sam will also demonstrate Excel working, so you can actually access Octo through into Excel spreadsheets. So where are we? So a year ago we had the initial production release, and that was a read-only access. Where we are today is, and I'll talk a little bit about this later, but we're actually doing a continuous integration, continuous delivery of our software. So Octo is essentially usable as soon as we release some functionality that becomes usable. So insert is usable today. Update, in fact, became usable right after I created these slides. So insert and update are usable today. Delete is the next thing we'll work on, and then there's a bunch of other functions. So the idea is that the initial production release was a read-only for reporting purposes. Octo 1.1, which our target is the first quarter of next year, will be essentially read-write functionality. So Octo will look like a SQL database. So if you're an M user, you can use it as an M database for reporting, M application with reporting through Octo. Or if you're just looking for a straight SQL database, you'll be able to use Octo as a straight SQL database as well. And then beyond that, there'll be additional SQL functionality. One of the nice things about the software business is that there's always more work to do. So you're never bored. Okay, now for an Octo demo, please go to Sam's talk tomorrow, I think. And I'm not going to show you Octo today because Sam can say a lot more about it than I can. Okay, let me talk a little bit about what we're doing with DevOps and continuous integration and continuous delivery. So, the basic stuff for that is, can you run in a container? The answer is yes. And when you have a Docker container, if you want to spin up instances with using something that manages containers like Kubernetes, the answer is yes. So all of that is yes. The other thing that we're doing is, as a 100% free and open source project, is we have a continuous integration pipeline on GitLab. And what that means is that when one of our developers wants to merge code, we expect that pipeline of automated tests to pass before that code is merged. So in principle, whatever is the latest master for any one of our packages on GitLab is in fact the functionally complete and usable. So we actually blogged about that. And the way that we're releasing Octo, for example, is there are no, we do have releases like 1.0 and 1.10 and so on, but those are often like 1.10 will be a complete package of functionality, but each piece of functionality is usable as soon as the code gets merged, which is why insert has been usable for a while. Update just became usable. Delete will be usable shortly. So the way that we release the software is essentially you do a git clone of the repository, you compile it, and it's good to go. The one exception is YottaDB itself, where we have a fairly extensive amount of testing, automated testing that goes on, and that actually runs on our servers because we can't run it on the CI pipeline. And we've blogged about this, so you can go read all about it on our blog. Talk a little bit about the ecosystem. So for language wrappers, we have Node-M from for Node.js, and that's thanks to David Wixel, and he continues to maintain that. And then Perl, as I said, is done by Stefan Trabi. Now, one of the more interesting things that has happened recently is this is actually some work that has been sponsored, I think, in part at least by by Raphael. That there's a person in Birmingham, England, who is both a Linux person or an open source person, and he's also into M. And we actually have a guest blog from him recently. So he's been doing a lot of DevOps work. So one of the things that he's done, for example, is develop a dashboard. So with this dashboard, you can see YottaDB, essentially monitor the performance, review it using a combination of Prometheus and Grafana, which are standard tools for doing this kind of work in the DevOps and system administration worlds. He's also developed using an open source package called Thea, a development environment for VistA and M, and I'm guessing YottaDB. It's maybe just the YottaDB dialect that runs in a browser. And again, all of this is open source, and you can go to his GitHub page and download it and use it. So this is just a screenshot. The other interesting thing that's been happening in the ecosystem recently is something called JSON hives. And Steph Lally he's a VistA developer who does contract work. He's based in Amsterdam. And when he's not actually doing VistA development, he's been developing this package called JSON hives, which is a JSON document store. The idea being that it will be functionally competitive with MongoDB and Couchbase and JSON document stores like that. And this is still under development, but he's making good progress. I've seen some demos of his work, and it's pretty impressive. So let me talk about the YottaDB roadmap. What we're currently working on is something called application independent metadata. I have a whole talk on this tomorrow. And the idea is that every application does things like cross-referencing. And that's because you've got data that's stored in pieces of global nodes. And you want to access data by content. So if you're looking for patients called Bhaskar, Bhaskar is never going to be a primary key, but it's going to be a piece of some node somewhere. So every application creates cross-references. And applications keep doing this over and over and over again. So it's kind of a case of reinventing the wheel all the time. So what AIM does is it's application independent metadata. So you can define what the application schema looks like, and then AIM will handle the cross-referencing for you. The initial use of AIM is we're going to use it for Octo. Octo doesn't use it yet because we need to still map some fileman idiosyncratic files. But once we do that, it'll be used by Octo. The idea is that you can just invoke it on demand. And like Octo, it'll just ensure consistency of data and metadata by using triggers. So and of course, we're continuing to work on YottaDB and Octo. So what are we doing going forward? We have, we want to go forward with our successes and our strengths. So what is, to the best of my knowledge, the largest VistA system anywhere in the world, which is the Hakim system from Jordan, that's running on YottaDB. There are really huge banking systems running on YottaDB, and these are banking systems with 40, 50 million accounts. And they're outside the US, but when you talk about computing, it's the number of accounts and number of transactions that matters, not necessarily the balance in the bank. And these are these large banking systems that are live on YottaDB today. And we have customers who are paying us to support their access for YottaDB using Go and SQL. Now, where have we not been so successful? And by that I'm saying, waiting for success, and that's IoT, where YottaDB runs on a Raspberry Pi Zero, for example. So you can get thousands of database accesses per second using just a consumer-grade micro SD card on a Raspberry Pi Zero. Now, it's a good technical fit. We're still looking for that first adopter who can then guide us to say what else we need to do. And maybe once we have the Python API, Python wrapper in production, maybe that will come. So if you have any ideas on that, please let me know. But I still have hope, but so far we haven't found any real success there. And there are things that that we're still working on that we know we need to do more. So we have an administration and operations GUI that's functionally complete, but it needs some polish. And Sam's going to be presenting that on, I think it's Sunday morning. And I think you like that. So certainly tune in and watch that talk. Recruiting is a continuing challenge. So it was never easy finding the kind of talent that we needed to do development in our code base, and it's continuing to be the case. So we had one of our developers a couple of years ago was hired by Google at almost twice what we paid him. So we can't afford to do that. So it's a continuing challenge for us. And marketing, I think, has been one of the weaker areas for YottaDB. And we were doing something that was paused for the pandemic, and we need to figure out how to resume that. And again, we may need to find some partners. This is just something that I'm doing a fair amount of thinking about. So that brings me to the end of the actual talk, and I'll open it up to questions now. So let me stop the presentation, and we'll go to discussion. So any questions?
So I'll jump in line since I'm a fast talker. Could you elaborate a little on the implications of using GTM, guaranteeing to have backwards compatibility after a certain amount of release time for the GTM stuff?
Well, I mean, ultimately what gives you confidence in software is testing.
Mm-hmm.
So we take the GTM code base, and then whatever is new in that code base, we read the release notes, we look at the code changes, we create automated test cases. And so that's what gives us the confidence in guaranteeing that the backward compatibility.
Does GTM release their test cases as well?
So GTM does not release their test cases, but at YottaDB, we create our own test cases for GTM functionality.
So that means like the write command, you might have different code that make sure the write command does all the things it's supposed to do from historical point of view and from GTM.
So it turns out we don't actually do that basic test, because it turns out that back about 2016, FIS actually did a one-off release of the test system as it was at that time. And they released that under an open source license. So we adopted that, and we're basically building on it. So something like the write command or the basic M functions. There are existing tests in that we adopted from the GTM release from 2016. Now, where let's say we added a new like a new ISV, the new $zy suffix ISV. So we will clearly write tests for that. And where GTM has made changes, the big hole that we found in the big bug was in their they rewrote the locking code, the mlock code. So we wrote our own tests for that, and then when we wrote the test, we found an issue with GTM. So we're under very high contention. It is possible for two processes to get locks that they shouldn't have. And at least one site, it caused a fileman to run away, because fileman was using mlocks to control the number of processes that it started.
Okay. So you see testing as very important. One of the $ZY function or variables that you created for SQL was $ZY or Z, or was it
Yep.
$YSQL?
ZYSQL null.
Okay, and that was added because the null in SQL is its own unique concept, and it's not really a mumps concept at all, right?
Correct. Though there's a whole lot of detail about compromises between the empty string, which is the M version of a null, and a SQL null, but that's why that ISV was created.
And because you're open source, you do accept output changes to code if someone needs to have it, and they convince you that it's worthwhile to put it into YottaDB.
Sure, we've had people who have submitted enhancements, and we've accepted those enhancements. And in fact, we have one pending at the moment where someone from our community has sped up they've rewritten the garbage collector to speed up the garbage collection. So we're going through a process of testing and code reviews and so on, and at some point that will be integrated into the code base.
Not going to give up. You're not going to give up performance or exactness just to have something from somebody else.
Well, I don't quite know what you mean there, David, but we don't intend to give up. Well, actually, let me back up for a second. From a philosophical point of view, if the code doesn't have to work right, it doesn't matter how fast it is. Oh, I'm sorry, if the code doesn't work right, I can make it as fast as you want it to be. So,
Yep.
so functional correctness for us is always priority one, and then performance comes next.
Okay. I'll be quiet and let somebody else ask you a question.
Come on, this is not a shy group. Please ask.
But we're on national television.
Well, international actually, because we have people from all over the world. But anyway, so I guess thank you very much. And anytime you have any questions, just email me or reach out to me. I'd be happy to answer them.